Today's topic is Spark DataFrames, distributed data and processing. And today Dan's going to be covering data storage, data transformations, best practices, and then some additional resources as well. And our presenter today is Dan Anderson. He's a SAS programmer on QDAS. And so now I'm going to be turning things over to him so he is able to give you more information. And then Dan, did you want to share your screen at this point?
Yes, I will remember to do that this time. Okay, share this. All right, seeing the screen.
Yep.
Perfect. Okay, so thank you all for coming again. This is going to be our third topic discussion about Spark and the transition from SAS to Spark. For those of you who were not able to join last week or even in the first session, we did recently get approval on everything, so those recordings should be coming your way for your viewing at your leisure, and then also we will, if there's as demand meets, as needed, we'll do some encore presentations of this. So just to let you know, today everything I'm presenting is in a notebook. It's in a Markdown, primarily with Markdown and some code. It's in a Databricks notebook. It has been shared with all users of the space. So if you have access to, in your workspace, CDR, PDA, QDAS, the SAS transition office hours presentations, and the topic 3, final, like Spark DataFrames, distributed data and processing. You can follow along if you'd like. You can also just reference that afterwards for your own edification. So I really appreciated the feedback from last week. I know that last week's presentation was very theory heavy. Unfortunately, this one's going to be it's also going to be along those lines of theory. I've got some practical components, but this should be the last that's really theory heavy. So I just want to setting expectations on that. I do want to see as many questions as possible, and we'll get to them. That's what Derek and Colton are looking forward to. So as a basic introduction, we're going to talk about distributed systems and understanding them more thoroughly. Last week, we talked about the architecture of a distributed system and how to connect our data, like connect to different data sources. Also, if you didn't see the kind of the big news was that the R clusters now have access to the CDR, the data catalog. So that is something that, a lot of people have been waiting on before. So this time we're going to talk about how do distributed systems work as compared to what we're familiar with. So specifically, the question always comes up, why do I need to know this? You're not a computer scientist. It may not be all that exciting to you. And many things are not that important for what we do in data science and analytics. However, SAS Viya is a single compute source and stores all of its data as SAS7 BDAT files, which are both inefficient for working with large data. Databricks uses a modern distributed approach for faster data reading, primarily, and more focused data processing. And so these are fundamentally different approaches that you'll need to understand in order to modernize your code from SAS to utilization in the CDR Databricks environment. And so I'm not going to go, I'm trying not to go too in the weeds on any of this, because I want you to at least get a gist of why does my code have to be different? Why can I not have exactly the same code, even for like a data step or something like that? And at the end of this, my goal is that you will understand the distinction and principal concepts of distributed computing and distributed data storage. So just to clarify, when we talk about distributed, we're talking about the fact that, all of us on our compute clusters now have a driver node and then multiple worker nodes. And that means that the work is sent off and distributed to those workers and then orchestrated by the driver node. So we want to talk about the distinction and principal concepts of distributed computing, like the processing itself, but also how is data stored in a distributed system. You'll also understand the fundamental differences between a single compute system implementation in SaaS versus the distributed compute systems of Databricks. You'll be able to explain the differences between a Spark data frame, a local data frame such as Pandas or R, and a SaaS data set. And you will understand the basic pros and cons of a distributed Databricks system, including how to leverage the strengths and also recognizing the cons in best practices. My assumptions are that you're familiar with at least some of the core concepts of the previous 2 SaaS transition office hour sessions. I understand that you may not have all been able to attend those. At the end, we have hyperlinks to the content, but I'm not expecting you to know too many details about those, just mostly, that you can create your own notebooks within Databricks Workspace and set the permissions as needed. You can connect your notebook to your org compute clusters. You can mount your org's S3 workbench to the Databricks file system. And you're familiar with your org's compute cluster architecture. Again, just driver and worker nodes. My outline for today is going to start with talking about data storage. Then we're going to talk about data transformations and data processing. And then we'll talk about best practices, as well as I have a bunch of additional resources at the end, because I think this is really interesting stuff. But I also am not going to force everybody to have my same taste and interest in computational resource management. So one of the questions that I initially had when I came into SaaS was, why am I hearing all these different things? Spark, Hive, whereas before it was just SaaS, right? And the reason is that really SaaS was proprietary, and it did 2 things. It had its own data storage component, as well as its data transformations, data processing components. So you had like procs and data steps that all went through like the program data vector. Now that we've gone over to an open source format, similar to with like Databricks, we have to adapt to different types of data storage and different types of processing methods for data transformations. So for example, in a non-distributed open source environment, we would be talking about like flat files such as CSVs, or that's kind of the easiest one to talk about, but even your Excel files and things like that. And then data transformations, normally on a non-distributed system, would be talking about using Python, Pandas, DataFrames, or R data.tables and functions for their local data objects in a driver node. In the distributed system, we have we have the data storage component, which is going to be primarily CDR, like in the data catalog. So we've got like Hive, which is kind of a SQL-like environment. And then the idea of Parquet files. And then for data transformations, we have the idea of Spark functions for Spark data frames being distributed amongst the worker nodes. So with data storage, what I wanted to try to help you understand and get a sense of is the SaaS, how is data storage different in a single node versus distributed? So a SAS 7b file is effectively, you've got a flat table, kind of like your CSVs, and then you've got a supplemental component that carries the metadata. And that's basically everything that gets spit out when you do a proc contents, right? Size, create dates, variable formats, variable names, all these other things. But so to do the similar thing in CDR, we have Parquet files, which house all the data. And then we've got 2 types of metadata. So first, let's talk about how the data content is stored differently. If you look at like a standard SAS data set, you'll see like this, right? You've got your whatever observation number you've got your variables, 1, 2, 3. In square brackets, I make reference to kind of the metadata, but that would be stored in the metadata section. I've tried to lay out kind of the matrix, like the cell number here. So if we ignored obs, then this would be cell 1, 1, 2, 1, 3, 1, and likewise 1, 2, 1, 3, all the way to 1n. In Parquet files, in the CDR, so we look at the CDR, we look at its Hive, all this stuff, but the underlying data is actually in something called a Parquet file. And a Parquet file is effectively transposing every variable into its, like every column into a row, and then getting rid of the cell dividers and just having them as an array with commas in between it. So, imagine just that each column of data from the table is transposed and stored as a list. And these new lists are stored in an array. So basically, all of a sudden now, everything is just variable 1, variable 2, variable 3, with an array of all the contents in it. And you can see what I've tried to show here is that the contents from cell 1, 1 that were here are now here. So the contents of 2, 1 from here are now here, and 3, 1, and likewise, all the way to the end. And then in your second variable, likewise, instead of it going down like this, it's actually going across. And even more so, the captured like section here of the 2, like, or sorry, the content of like the first and second and third, these are referenced via indexes and all that other stuff that makes it a little faster to work with. The reason that these are done this way, and we'll have a chance to take a look at this in some illustrations, but this makes reading much faster. When you think about big data, the biggest limitation is loading in your data, reading the data, identifying which, like you're not usually going to be making changes to every cell within a 10 million obs data set. But you need to be able to quickly identify the things that need to be modified. And so by, usually we're making modifications to the columns and then records within a column. And so by transposing it and doing it by variable, we're going to be able to be much more targeted in where we do data processing. So what about kind of the metadata component of our SAS files, right? Like, well, in the CDR, and when we're talking about Parquet file, there are 2 types of metadata. Parquet files, and those are very similar to Delta tables that we'll talk about later. But Parquet and Delta files actually have metadata listed within it, but it's very basic metadata. Basically what it is it's identifying the elementary data types and nothing fancy about formats or anything else. It's basically, is this a string or not? Is this an integer or a double? Like, what type of data am I expecting this to be? And that's it. And that's all that cares about from the Parquet or Delta level. However, we talk about like more extensive metadata, like, putting in labels and things like that. Well, those can be expanded by using either Hive or even in like Pandas on Spark. Would be able to implement those things where you get a data type and labeling, and then you can also implement other ways of doing your automating some data formats. Not necessarily to the same I haven't done too much with the data format, so I'm not going to overcommit on that. But there is certainly a bit of the data formatting that you can manage. But that has to be done outside of just the Parquet or Delta files themselves. So some common Hive SQL questions. All right, what is Hive what is a Hive table? Hive table is basically a way of looking at Parquet files like this, where you have the columns and your variables all listed out. It's a way of looking at that, but almost like having like a secret decoder glasses that can automatically look at it like a SQL table or like a standard data frame or a standard like data table that we're familiar with. So that's what Hive does. And there's, this idea of this concept of what makes the most stable data storage and data editing capabilities. And those require what's called ACID tables. I put a link in here if you're interested in it. Ultimately, all that matters to you is that Parquet files are not natively ACID, which is why anytime you're doing work in the CDR, you can't just delete rows or add columns or things like that very easily. It's because it doesn't have this capability. And so that's why you have to just drop the entire table and recreate it and reload it. Delta tables are an addition by Databricks, and they've made it open source. It's basically an extra layer on top of the Parquet files that enable transactional logging. And because it has this logging mechanism, it can take the original data and modify it appropriately and track those modifications as needed to include updates and deleting and certain merging capabilities. The other big thing I've seen about Hive SQL as we've been working with it is, the idea of a view or a temporary view and when should it be used. I've seen a lot of people, they were used to having temp tables, and those don't currently exist, right? So then they were using temp views. And the temp is great because once you close out your session, it's gone. And you don't have to do like a drop table statement. But I just want to, for any of you who are not familiar with views, recognize that a view is effectively a predefined table that can be permanent or session only within a schema. However, it's purely a logical object with no associated storage. So when a query references a view, that view's definition has to be evaluated in order to create the underlying, the actual data that needs to be processed by this future query. They're great for things when you only need to tag that table once and very rarely, because it saves memory or saves hard disk space. But it's very process intensive if you're referencing that same view multiple times, because each time you're referencing it, you're reprocessing all the data and recreating all the content of that view. So it's great for reports, but it's not necessarily the best practice for our Hive and our CDRs. So talking about Parquet files and just metadata, I wanted to go back to a use case from last week, where I imported the zip code data and I created a new column about New England. And this is just showing what that looked like. Here, I want to point out, so here is, if I do like a data frame and I print the schema, that data frame schema is the same as the Parquet schema underneath. And you'll see, again, like it just gives strings, integer, there's doubles, but there's really no great formatting, date, time, interesting formats or anything like that. It's just the bare minimum to retain what type of, like, the data type for later recognizing and processing into a better format. So here's like I said, this is the data frame metadata versus the Hive metadata. So your Hive metadata, like if you can run a describe extended, and it will tell you all the contents of the metadata. And it tells you the time created, how the stats, all this different things. And you can see clearly the Hive metadata is much more extensive than your data frame or Parquet metadata would be. Also, an alternative, I know sometimes if we have to like replicate the process, there is this create tables or show the create table that we use frequently, and it will actually print out the full create statement of the data source and everything. So that way, if you needed to create your own schema for something, you can just copy paste and work with this. S3 data storage form methods, right? So we talked about Parquet files and they have some metadata. What we didn't talk about with is that Parquet files are usually broken up because they're meant to be accessed by different places, different times, and trying to be faster, like as fast as possible in processing and reading through the data. So here, all I've done here is I've taken that modified data frame that I created from the zip codes file, and I'm outputting the Parquet file to a mounted location. I'm doing this to show you that what does my Parquet file actually look like. If I do a listing here, you'll see that actually it's a few internal logs, and then in this case, because the data is not huge, it's just one file. It's got this weird name to it, but then there's a .parquet. You don't really want to read it directly like that, but you know, like human readable, it's not that great. But that in there will encode, it carries with the metadata and everything else. And you can see here what I've done is I've output it to a Parquet file. Then I've created a new data frame where I read in the Parquet file, and I'm doing a print schema just to show you that that basic data frame schema and was stored within those same Parquet file, that single Parquet file. So referencing that alone gives me my basic data type schema. Moving to Delta tables, you'll be hearing more and more about Delta tables because, again, it's something that Databricks created so that they could create, so their large, catalog data tables could be ACID compliant, and therefore you can update them and you don't have to constantly drop them, and you can track all these changes to it. So here I've done the same thing where I've output the contents of the zip code data frame as a Delta format and to my mounted location. And then I'm running a listing to show you the contents of that. And then I will read in the contents of that Delta and show again that the print schema is going to be the same content. What you'll see here is in the listing of that Delta, my Delta data, it, in this case, output two different data files, and then a subdirectory of logs. The subdirectory of logs is really what makes a Delta table a Delta table. It tracks the changes of each transaction. And these Parquet files still contain the same metadata, and they're the same exact, it's cut up into two in this particular case, but that was just how the system was running it. And so it reads it in and gets the exact same outputs. So I just wanted you to have a simple kind of a basic sense of how is your data being stored? How are you accessing the data? And this will lead us into our next part. But I also wanted you to see how is it different and why is it better than a SAS 7 BDAP file? Again, I'm a SAS person. I've been doing it for a long time, so I don't have any problems with SAS. I've loved it, but it's not meant for reading at the speed that is required for modern distributed computing. I'm running a little behind, but I will take one question if there's anything in the chat or anything somebody wants to talk about.
Dan, we literally just got a question in the chat. Does there tend to be a speed difference for writing to Delta versus Parquet?
No, not that I've viewed. I haven't done it with huge things. In this particular case, I used a mount so that my worker nodes have direct connections as well. But that's something we're still testing out. But again, ultimately, your underlying data is just the Parquet files. It's the same thing that came out with the regular Parquet. It's just this one additional log, which has like it has a JSON file and an internal read file and a commit comments and successes.
And Dan, one other thing about Delta is, from what I understand, is that it actually does contain metadata, existing metadata. So even though it's a file, it is considered basically to be a table without a database. And so if you're importing a Delta table, a Delta file, like it will potentially have the ability to read that metadata and assign the proper data types to the data frame schema. Compared to a Parquet, it's you can do an infer schema equals true, and it'll try and assign Spark will assign what it believes to be the data types, but it may not be the data type you want in the data frame. Whereas with Delta, it actually does read a metadata file and assign the associated data type.
Okay, I'll have to look into that as well. I do know that, yeah, with both of these Parquet files, if you were to open them and ignore all like the hex numeric stuff, at the very bottom, you do see like a human readable schema that basically looks like something very similar to this output here. So yes, if you want to be able to update a file, you'll want to do it as a Delta table. If you want to be able to delete observations or delete content within a table, you'll want to use a Delta table. So pretty much everything that's being processed through SAS right now that goes into the CDR is a Delta table. And most of the stuff that we're currently creating, when you create something there, is also kind of by default in that realm of Delta. But it's not, we haven't been able to take our legacy content up to the Delta level yet. So until that, for that reason, you can look in the catalog in your catalog up here and scroll and see, you know, what type of data table is it. And I bet if you did a describe tables, it would also probably tell you what you know, if it's a Delta table or not. Parquet, yeah, but you know, the read-only component, sorry, Brittany, I'm reading your comment here. So if you want to be able to update, delete a file, sounds like you want to save as a data file, Delta table. That is correct. If you want to be able to modify the contents of a table without having to like delete the entire table and recreate it. Parquet, and you continue to say Parquet, though, might be better if you want it to be read-only. Yeah, yeah, if you want to put it out there and have it as read-only, it's fine. Although I will just say in general, your underlying files for a Delta are still Parquet as well. So it's just whether or not you would have this Delta log. So yeah, that's up to you and your practices. I think that for me, the added functionality of a Delta table with the Delta log is worth me just as just kind of a rule of thumb to constantly just do Delta as opposed to, you know, trying to recall which one's which. And, or more importantly, you know, for this particular table, do I want to put it as a Parquet or as a Delta? I'm like, it's so minuscule the difference, and I get so much, like my return on investment of using a Delta is so much more that I would default as a Delta. Because again, you also, your data sets are, you know, your tables have an owner component to it. So when you know, if you're setting, you know, the ownership, then that's also where you're at. All right, I will move on to talk about data transformations. Oh, geez. So basically what I wanted to illustrate is the difference in how our data is being accessed, changed, like accessed, processed, and stored when talking about the single node processing specific to SAS versus a distributed Spark data frame. So when we talk about a SAS transformations, the primary difference here, we're going to focus a little bit about by row processing, and by default, everything is processed for each proc and data step within a SAS table. Whereas in Spark, we use this, it's by column processing, and we have this sense of lazy evaluation, which I'll expand here. So if you recall, for any of you who get really deep into SAS, you know, here's a standard data set or data step. nothing exciting. Making some small transformations on the variables, changing the lowercase and modifying the length variable, not the length value of a variable. So here you start in SAS, you start with a SAS data file. And then you go into the PDV. You read in one row, you store it into the program data vector. Then you go through each of these things, like you loop through your data steps and make those, you apply each of those transformations to the content of the PDV. So here, make has been lowercase, model has been lowercase, type hasn't done anything, but we did bring it into the PDV as well as everything else. And then length has been multiple. I think I meant divide by 10 or by 100. Oops. Yeah, I meant divide by 100. I'll change that later. And then that first row goes into the output data frame or data file. Then you go to the next row and pull in the second row and you run that process through the PDV and output that, and so on and so forth until you get to the very end of your data file. What this means is that, again, for every row, every piece of data in this data set is being moved, read, stored somewhere internally, potentially modified, and then stored to a secondary location afterwards. So, you know, in this, we've created one data file where every row has been processed. Any additional data steps, if we wanted to take it and do another data step, that would do the same thing, where we would have to read in every single item into the every row into the PDV, modify it, and then put it out into a new data frame or a new data file. And even if we, use the same data file name, right? Like you can set your output data file name as the same as your input data file name, but it doesn't change the fact that the data all has to get processed, and there's a lot of input output processing, reading and exporting of the data, and then it just goes back into a single data frame. So in that case, then yes, the number of or the amount of hard disk space that's being occupied by these two data sets is reduced, but the amount of processing required is still the same. And that's kind of what I'm calling out in this case. With Spark data frames, to do the same thing, we'll take it as, all right, here's your initial data file. We're going to bring it into a data frame, which means that we're transposing everything into an array of each variable. And then once we've got that initial data frame, we map the intended transformations. So the function of lowering and lower and the division of 100 here, but at this point, we're only mapping it. We're not actually performing any calculations. We haven't done anything with data at this point. It's not until we have to actually call on that data to output to somewhere that this process is actually executed. So that's the idea of lazy evaluation. And it's optimized. So then we put it out to a final output file. Here I'm retaining it as like a Parquet file, because there's no reason to have to do all this additional work if I know that it's next time I'm going to use it. I just want it to be already prepared as a Parquet or Delta format. And you'll see that instead of reading in every single row of data or every column of data, I can actually just immediately just pass this one off, right? Like there was nothing that had to be done with it. So I just take it from the input and immediately transfer it into the output table. No processing required. Likewise, but when the ones that actually have transformations are processed, those are the only ones that are being processed. So here what we've done is we've created two data frames. Again, they only track the transformations. And we've then only processed the relevant variables during the write or show action request. And at the end of the day, we've created one data file. And it's a distributed file type because in this particular case, like I said, I've outputted as a Parquet. Each additional transformation that you wish to add as a separate transformation step would ultimately just add an additional mapping into this. And you can even reuse the same name. And in which case, then, I could map all these where I have data frame in is equal to data frame in, and then the transformations. And then that would reduce the number of locations where I'm tracking transformations. And it can be a little more efficient that way. One point I wanted to make as well is that there are sometimes you'll see something's running really long or you're not sure what's going on. All of this, again, they're transformation mappings, and then the data is only actually being called and used in the final stage. So you can track in your compute, you can look at the compute section in your GUI here. And if you would only see the stuff that you have access to, CDR, PDA, QDAS, my compute cluster. You can't access the driver logs, but you can look at metrics. And when you look at the metrics, you can look over the last 8 hours. And these metrics will output your CPU utilization, your memory utilization. And then notice that, like, for example, right now on my memory, I've got 10 gigs of cached information in there. Databricks tries to hold some stuff as much as possible so that it doesn't have to recalculate for you. It's a double-edged sword. But just because something's cached doesn't mean that it's not easily ready for being disposed. And there are also some manual ways of targeting cached stuff to be sent off to be junk. But you can look at all these metrics, the amount of free file system space on your driver node as well. Are there any questions about data transformation content here? I like to think that means I did a really good job. But if you come up with questions later, please feel free to let us know. You can put them in the help desk. Eventually gets to us, and we'll address it. I just wanted to call out some best practices for your shared resources, kind of related to this stuff. So when we're talking about data storage, think about how readily do I need this data? Is it an intermediate data set? Is it something that only I need? Is it something that needs to be in my schema on the CDR? So think about what your actual needs are before sending it one place or the other. Obviously, anytime you're using your schema, try to leave it clean for everybody else because it's your entire org uses it. And just make sure, like, if you're choosing to create a view, whether it's a temp view or a regular view, just make sure, is this really the right usage? Do I want to be creating this view every time I'm targeting it? Am I hitting it more than once? Or am I just creating it? Am I only needing the contents of it one time? For your S3 workbench and the way that you want to store your data, think about who else may be wanting to access this data and what other systems would be needing to use it. So for example, in this previous one, I brought in everything as a CSV, but I know in this example, I'm only going to use it as a data within DataFrame calculations and Spark calculations. So it makes more sense for me to store it as a Parquet file or as a Delta file than for me to do the extra processing of transposing everything back into a CSV format or an Excel format or anything else that then next time I go back to load in my data, I'm going to have to undo all that. However, if you're creating a report that others need to be able to open as an Excel file, then clearly do it that way. But those are just some thoughts to keep in mind when you're working with this stuff. And then with data processing and Spark data frames, do I need to retain an intermediate data frame? Do I need memory to be allocated to an additional mapping or can I build that mapping transformation into my previous data frame? And then, as I wanted to mention, cell memory caching. There are times where you may have noticed, like you run, like I did it earlier today, I was running a listing, DB utils listing, and I know that I had removed the file, but it was still showing up. That's one of those cases where Databricks is going to try to hold on to your most recently called data and keep it cached so it doesn't make you process it a second time. But if that is happening to you, just either detach and reattach your compute resource to the compute resource here under run. You can do detach and reattach, or you can go to clear the state of the current thing. Or honestly, sometimes I just create a new code block and run it in that new code block because that code block doesn't have anything cached. And then just for my purposes of my presentation, just trying to be a good role model here. I don't need this content on my data in my anymore in my S3 location. So I'm removing the content there and I'm unmounting my mount. Hopefully, just to summarize the stuff that we've been talking about and the goals, my hope was that you would understand the distinction and principal concepts of a distributed computing and distributed data storage, looking at the two components that SAS was merging, like conflating into one service. We've got to tease it out as two separate services. You understand the fundamental differences between a single compute system implemented in SAS, where everything's processed by row and everything is constantly being moved with a lot of IO resources dedicated, versus a distributed compute system where you're doing it in a Spark data frame. You're only affecting the proper, like it's only doing mapping transformations, and then when the transformations are actually run, it's selective to the specific columns that need to be used. And then you can explain the differences between a Spark data frame, a local data frame, or a SAS data set. And that's mostly about a Spark data frame having just the log transformations. Your local data frames had data stored within there, as well as the additional metadata to it, as well as, and then your SAS, which also had data stored with additional metadata. And just as a preview of what we'll be talking about in the future and what we have mentioned in the past, you'll start to understand some pros and cons of distributed Databricks. So one of the big pros is that data processing is minimized to minimize the input output and the transformation processing. Basically, there's no context switching between each variable, like reading through a row and having to look at the different rules for each different variable. You just apply all the changes for one variable to everything, and then you move on to the next variable and do it for everyone, or as dictated. And then, of course, distributed processing is able to be used, and so you can send the work off to the worker nodes and use those additional memory resources. One big con, of course, is that we don't have a PDV. The PDV was essential for us being able to have like first.var, last.var, retain statements, being able to do lag, and even some of the SAS array functions. So each of those is going to have a more difficult way of translating it. We've provided code examples in the previous data camps for many of these. I think pretty much all of them, but we will also address those in the future. And then I will, God, I don't know why I just talk way too much. I'm going to say it's because we started 5 minutes late. But if there are any questions overall about distributed data and processing, I will call your attention to lots of additional resources. These hyperlinks don't work yet because I need to have, once they're posted in Portal, I'll use the hyperlinks to so you can get the slides and the presentation recordings. Here's some good documentation and blogs about really understanding Delta Parquet files. I also had some additional questions that have been going on with CCSQ channel this past week, the analytics channel, about DataFrames and Spark interpreters and Spark APIs. So I put this in here for you guys to refer to. I think it's interesting stuff, but I'm also not, I don't think you need to know all of those details to be able to do the code transformations that you need to do in the future. You will need to know how a data frame has your data, in arrays, the column is processing by column. Those things are necessary to be able to develop your code changes. Sorry, I will, as I said, are there any questions?
Dan, there's none in the chat right now that have not yet been answered by team members.
I apologize for the dense nature of a lot of this content. I'm trying to make it as accessible as possible. But this should be the last theory heavy, which is not to say there won't be theory in the future, but this one was definitely much more theory heavy.
Thank you, Dan, so much for sharing.